right, our final volume formula for the year is going to be the volume of a sphere, okay? The volume of a sphere formula looks a little bit like the surface area formula. If you remember, the surface area formula for a sphere is 4 pi r squared. Some little tweaks in that formula. It's now 4/3, and anytime you're dealing with volume, you have to take all 3 dimensions into account. I'm not even sure if you've noticed that in the other problems, but if you notice, like when you find the area of a base, you're doing something that has to do with the 2 dimensions of the base. And then when you multiply by the height, you're dealing with a 3rd dimension. So there's a 3-dimensional aspect to finding the volume of a sphere as well. You're going to be cubing the radius. So for area, which is in square units, it's 4 pi r squared. For volume, which is in cubic units, it's 4/3 pi r cubed. So I like the fact that the square unit formula has r being squared, and the cubic unit formula has r being cubed. Anyway, mostly just a matter of sticking your value into the equation. So here's your circle, or your sphere in this case. We have a radius of 6, so we're going to take 4/3 pi r cubed. We're going to cube 6 there, and 6 cubed is equal to 216. Okay, so you want to simplify this down a little bit. You're taking 4/3 of 216 and you're multiplying by pi. Okay, remember that's 216 over 1. So you could take 4 times 216 and you could divide by 3. Sometimes it'll be a fraction. This one did divide out evenly, so we ended up with 288 pi cubic units as the final volume. All right, the numbers can work out a little bit differently. Just make sure you've got a radius and not a diameter. So the numbers will be a little bit uglier if I give you a radius of 5, because 5 is not divisible by 3 for the 4/3. So that would be 4/3 times pi times 5 cubed. 5 cubed is 125. 125 times 4 is 500. Okay, so you're taking 4/3 of, I'm sorry, 5 cubed is 125. So you're taking 125 times 4/3 times pi. And same kind of thing here, 4 times 125 is 500. That's the 500 I was mentioning before. So you'll have 500 over 3 pi, or you could write this as 500 pi over 3 cubic units is probably what they're going to write in the back of your book. So again, don't expect that you're always going to get whole number answers. You'll get some answers that are ugly, and that's totally to be expected. You'll also be asked to do a couple application types of things. Let me just mention one typical type of example that you might see. Maybe you're given like a silo or something that's maybe got this sort of shape. Okay, it's kind of got like a dome type of thing on top. And let's say that this thing is, 10 feet across and it's 20 feet high, something like that. Okay, so you've really got 2 things here. This is called a composite 3-dimensional solid. You've got 2 different shapes. Okay, so you've got a cylinder. Okay, the volume of a cylinder is equal to the area of the base times the height, or you can use pi r squared h if you want to. The area of the base is going to be 100 pi. The height is going to be 20. Okay, so that ends up being 2,000 pi cubic units for the volume of the cylinder base. Okay, notice you have a hemisphere at the top, and you look at it on the surface, you say, wait a second, they didn't tell me the radius of this thing. But you should be able to look around your diagram, and you know, for example, they might tell you that the whole thing has a height of 30, and then you would notice, oh, if I put a radius there and it goes up there, I've got 20 here, I've got another 10 that would go there. Or if they didn't tell you that, in this case, you don't even need the height of the whole thing, because the radius down here should be the same as the radius up here. So the radius is going to be 10. You're taking 4/3 pi times 10 cubed. Okay, 10 cubed is 1,000. You're multiplying 1,000 times 4/3. So 4/3 times 1,000 times pi. It'll end up being 4,000 pi over 3. Okay, but be careful. It's a hemisphere. You're going to have to take half. Okay, and if we divide by 2 there, it should be 2,000 pi over 3. Okay, so the final volume here, you're going to have 2,000 pi. And you're going to want to add 2,000 pi over 3. You might want to change this into thirds. So if you had 2,000 pi, just so you can add them together, that'd be 2,000 pi over 1. We can multiply the top and the bottom by 3. That would be 6,000 pi over 3. And then we want to add 2,000 pi over 3. And in the end, you would end up with a total volume of 8,000 pi over 3 cubic units. Probably how I would write that. So keep that in mind. You may need to break up a shape. They might have a pyramid involved, they might have a sphere involved, they might have a cylinder involved, but you should be able to find the individual volumes and just add those together to get the volume of the overall shape. So hope that helps in the last section of the year in geometry.